In 1995, right after Christmas, a very old friend of mine came to visit me in Berkeley, and he was very excited. He had had this wonderful idea he was eager to tell me about. And we went for a long walk, and he told me that the idea was to use distributed computing to work on SETI, the search for extraterrestrial intelligence. He was trying to think of something we could do today in 1995 that would get the public excited about science the way that going to the moon had made people excited 25 years before. And in 1995, that was at a time when the internet was becoming very popular, and a lot of people were getting powerful home computers and they were connected to the internet. So he recognized that there was this new computing power available not in supercomputer centers or in laboratories, but in people's houses. And he tried to think of a scientific problem that would interest people and could make use of that computing power, and he thought of SETI. So about 2 or 3 years later, we managed to get some money to start the project. By this time, these other projects called GIMPs and distributed.net already existed, so we all started at about the same time. One thing that we did differently in SETI at home, we made our program look like a screensaver. So when you're not using your computer, it would start doing its work, and it would also show these graphics in your screen, and it would have a three-dimensional display of the signal analysis that it was doing. And because I think a lot of people are interested in SETI all over the world, and also because people like to look at pretty pictures on their screen, a lot of people started running SETI at home. The number of people running it, a total of about 5 million people now have downloaded and run the program, and of those, approximately 500,000 still run it every day. What that means is that in one 24-hour period, we get about 1,700 years of computer time. If you measure that in terms of computing power, floating point operations per second, that makes SETI at home by far the world's largest and most powerful supercomputer. What we've been working on for the last couple of years is to take this technology that we've developed for doing scientific supercomputing using home computers and to make that available for scientists in other areas. In other words, to develop the paradigm of what we call public distributed computing so that it can be easily used by a biologist or a physicist or somebody studying earthquakes or climate. We're developing a software system called BOINC, Berkeley Open Infrastructure for Network Computing, which is it's a package. It's almost like an operating system. You can, if you're a scientist and you want to do one of these projects, you can download this software, set up a server, write your application. Maybe it's even an existing application that you change a little bit to use this platform. And then with very little work, you can create a project that works like SETI at home. BOINC it's free, it's open source. Anybody can use it for whatever they want. It doesn't have to be academic research. It could be somebody who's interested in computer graphics and wants to make movies, and they make a distributed rendering system and get their friends to volunteer their computer power to help make their movie. Whatever you want, it's free software. Now it's very important to distinguish between what we do at SETI at home, which we call public computing. That means we're using resources that belong to the general public. Computers, home PCs in people's houses. Grid computing uses computers that are owned by organizations like universities, research labs, and companies. Now that's a lot different from public computing because these organizationally owned computers are usually connected by high-speed networks, so there's not problems with bandwidth or people turning their modems on and off. The computers are generally secure. We don't have to worry about hackers quite so much. Usually the computers are more homogeneous. They're all the same type of computer. We don't have to worry about Windows 95 versus 2000 versus XP. And all these factors make grid computing simpler in some ways, more challenging in other ways, but it's really a different technology than what we do, which we call public distributed computing. The size of the resource, the number of computers that might be available is extremely large. Today there's about 100 million PCs, privately owned PCs, on the internet. SETI at home is using 500,000 of them, that's half of 1%. We're hoping that maybe 10 or 20 times that many people will be interested if there's a wider range of scientific applications to work on. There's kind of a duality in public distributed computing. On the one hand, it benefits scientists. It lets them do science that would be impossible otherwise. And on the other hand, it benefits the public because it encourages them to learn about science. And my dream, the thing that sort of my vision of what I'm working towards, is a situation where the general public who has a computer, and these days most people have a computer, can go out there and kind of survey these different areas of science that they can work on. BOINC is written so that you don't have to choose just one project. You can pick, let's say, 3 projects and then divide your computer time 40, 40, 20, or whatever you want to do. Because public computing uses, anybody can use their computer, that includes hackers. And one of the things that hackers sometimes do is to send back results that are intentionally wrong. What we do in BOINC, the default is that each computation gets done twice, and we compare the results, and if they don't agree closely, then we send the computation to a third computer.